Hi, everyone. So I thought, before jumping directly into the talk, to give a bit of background why I even thought of talking about this now and why this is matters in today. So I'm just going to go down a memory lane from 2023. So we started, obviously, building CodeWords as an AI lab, trying to focus on how we can allow non-technical people to build software. We were mostly focusing on backend systems. And the thing is, the thing that we observe, even in the last 3 years, that the problem with all the generated code, it's still the same. Even with when we started with GPT 3.5, at the time, writing a small function, how can we make sure that it works? It's still the same problem now we have, even with best models like Opus or 4.7. The issue has always been the same of, OK, I have the code. How do I make sure that it actually works? How do I make sure that it's validated, deployed, and everything? And for us at the time, that was the issue that we're trying to solve in the product. However, today, what we're trying to solve in the product has become an industry problem, because now everyone uses LLMs to pretty much write code. And so whether you're using the same from GPT 3.5 to Opus 4.7, we know it's a massive move. But the same fundamental issue is OK, it generated something. How do I trust that whatever it generated is going to work, is going to deliver? What has changed is the complexity of what it's actually able to do, from generating a small function to generating entire code bases. But it's still the same issues that we face today. And one thing, and this is why we thought this can be an interesting talk, is it started as a product problem of how we can make sure that whatever the user's generating is trustworthy, to become an industry problem, because now everyone, all developers, are now moving to rely a lot on LLMs to generate the code. And so this is mainly going to be most of our learnings from the product, but also some of the learnings that we use to build the product itself. So going back, traditionally, in software engineering, it was mostly you spend some time when you're building a new feature, some time planning, design, implementation, testing, deployment, and maintenance. And most of the time used to be on the implementation. So we sit down, a couple of meetings, you figure out what is the roadmap, you produce a PRD, you have the designs, and then developers go on and they spend a couple of weeks writing the code, writing unit tests, and so on. And this is what we used to. And what basically happened, so I'm just going to give it as a chronological view, because actually most of the learnings we learn has not come from, in the past, things have been properly documented, but now with AI, because things have been moving really fast, actually people learn from X and from industry, rather than someone document these practices. So actually, most of the learnings is coming from individual experiences, people tweeting on X, and then people sharing what they've done. And the industry is adapting now to these and trying to formalize these into practices. And so we started, obviously, with 2023, when Copilot, ChatGPT, Andrew Karpathy, talking about the new programming language being English. And then we moved to 2024, Cursor, Devin, all the coding agents start exploding. And then 2025, where vibe coding got coined by Karpathy. And everyone was talking about the 10x productivity, shipping fast. And then 2026 came in. And we know early in 2026, when a bit of negativity started coming from vibe coding, to today, where even the creator of Claude Code, he said he's tired of the phrase vibe coding, right? And now we started seeing from vibe coding, we start seeing a lot of AI slop happening. And so this is the shift that has been going. And it's been moving really fast. This is just 3 years. An entire thing has shifted. That even the practices, people are learning the practices day by day. I mean, you're not going to find a book that tell you what is the current AI native software development. It might come in a couple of years, but because things are moving really fast. And again, this is all our learnings from here. And there might be a few things that will get refined over time. But what we all can agree on is that coding or generating code is no longer the bottleneck. It's no longer the problem. The problem is how do we make sure that whatever the code that we write, we can actually trust it. So it's about trusting that code has become the issue of integrating AI into the day-to-day software development. And so at least like companies who are very AI integrated, the new cycle that happens for them is that engineers sit down, they plan, they architect, they add the documents, PRD, and then AI does the stuff, write the code, does everything, and then engineers come back and review, make sure everything is tested, do a lot of QA, and then ship and monitor things. And the effort has moved from basically the start and the end, starting with planning things and all the discussions happening. And then at the end is like, OK, we generated some code. How do we make sure that things are running well? And we've seen that most of the actual resources are actually spent on those two, but mostly on the bottom one. So reviewing, testing, and QA. We've seen a lot of companies, they basically like have too many PRs that needs review. PR are like accumulating because it's much easier to get the code. But someone needs to manually review this. And now it depends on like, should you use a bug bot, but do you trust it to actually run? And so the bottleneck have moved to trust. And again, like some code from folks in the industry is like, the thing is now, if you let the LLM write the code, but you actually review it, you know what is happening, you write the test, it's no longer like vibe coding. This is the proper, so software engineering itself is just getting adapted. And now people are calling it like agentic engineering and so on. And we all coming to realize that now the issue is, can I trust this in production? You can easily get an MVP, but can you actually make sure that things run well in production? One surprise, and from here on, I'll start talking about what we've seen working. But the big surprise is the upside is architecting has now become much cheaper than patching like code. And this is actually quite nice because it means that we can, if we have very good harness and system to test things, we can actually go back and re-architect things. While in the past, tech debt has to be like the biggest problem. Like every time you write code and you patch things, it becomes harder and harder to go back and redo things in a proper way. But actually now, if you have a good system in place, it becomes much easier to actually even go back and re-architect things from scratch. We've seen some companies like doing entire migration. For example, like Lovable, before they went up, they migrated the entire code base and so on. And so biggest learning is like MVP now are fast, refactoring is cheap. And so the bottleneck is no longer tech debt. So what is actually should be the focus? The big thing we see now is focusing a lot more on building the system, writing the documentation, doing the orchestration of your repository, more than actually what comes after. Because once you have a good system in place, and by system I mean not just like MD files in your repo, I mean everything like connecting to your like linear tickets, how they are how agents have access to that, having a good like log system that agents can log every problem that happens, having a bearing in mind like how do we test the code. Once you spend a lot of time figuring that out, the rest actually it's gonna be, you're gonna see the productivity coming in. So it's actually spending a lot of time setting up a good system in place that will allow for testing, will allow for basically like validation and recovery. That will, then we'll start seeing the productivity. And this is what we've seen, like it's all about the testing spectrum. So if we learned something in the last 3 years, building the product and doing it, is that most of software engineering now is how do you write tests? This is actually seen, and one coin we use a lot, even in interviews, like we think all software engineers should be AI engineers now because it's less about writing the code, but it's more about writing the pipeline for these agents to write the code. And so most of the work going in, even architecting the system, is like, how can we actually test it? That should go in even before writing the system itself. So here are like few learnings. One is the architecture itself should be friendly to add unit tests. And what that means is having a, and again, this is from our own learnings. Different people will have different views of things. And again, we're learning things on the fly, and we see things breaking, things working. But so far, building things to be like stateless, modular, functional is the best way, because in that case, it's much easier to write tests. And because LLMs are now doing the bulk of the job, the boring stuff, it's actually fine to have a lot of like modules around, a lot of functional things. And it's, in the past, that would be like, the problem with having a microservice architecture is that you ended up writing a lot of code because everything has to be like self-isolated, contained. But with now LLMs in the picture, this is actually quite good because it means unit tests can give you a lot more coverage. And so we do that a lot. Even the way every service that we allow our users to build is actually a microservice. Stateless, is functional, and that makes it very easy for the AI to write the unit test for it to actually validate it works. The second big thing we spend a lot of time on is the environment and the sandboxing. With the new models, they can do quite a lot if you give them the right tool. Now is giving them the right environment that they can spin the entire cluster, whether that is like just a coding cluster or the entire front end, back end. But having an easy way in your system to be able to spin this, so that LLMs can do a lot of things, can fix bugs, can run tests, that will come very handy, especially when you come to run like performance testing. And the other thing is being able to destroy it like very quickly and have that completely separate from any production data. So now with that, the third part is using LLMs as well to detect. And we've seen there's a lot of like CodeRabbit, like Cursor Bugbot, and so on. But the problem with using LLMs to detect bugs, it's a recall problem. What that means is if it detects a bug, even if it's a false positive, it's fine, because an engineer can look at it and say, OK, maybe that's not a bug. But the biggest problem, the risk is false negative. If the bug bot says, OK, everything is clean, you're good to go, can you really trust it? And so the way we treat these LLMs that check code is almost like they need to pass for us to do the next thing. But it doesn't mean the code is safe. And so it's become like a prerequisite. Run as many LLMs, run Cursor Bugbot, CodeRabbit. If they raise something, consider it. But if they didn't raise anything, that doesn't mean the code is clean. So it becomes like a step that you have to do before you do anything else. And finally, and this is something we've seen coming now, is using a lot of like computer use and browser use. Now they're very slow, they're very expensive, things are getting better. But what they do is they help a lot when we have a human in the loop. So we have a QA tester that tests. We record all the interaction they do, and we bake that into the pipeline, the CI/CD. And so once everything passes, we run like one CI/CD end-to-end, which actually like has a whole user in the product. It goes, it spins, it writes something, it waits for it, it compiles, it tests. But it does the entire thing as if it's a human in the loop. But one caveat is this is super expensive. Like sometimes actually cheaper to hire QA engineer, like QA, from outsourcing them than actually have agents. But the good thing is if you've done it once or twice with a human in the loop, you can actually record all the interaction, and now you can have it as a CI/CD pipeline that give you extra trust that things work as expected. And finally, even with all these, it's still really hard to make sure that actually it works. But going back to the point I mentioned about refactoring is becoming cheaper and so on, we realized, and we started using this quite a lot, is building an A/B testing framework is actually quite handy. Because at the end of the day, we need to move fast, we need to ship fast. Even if you try to do as many of these testing and so on, a lot of things might actually break. And this is where, at least for a product like us, which are prosumer, ICP, and we have like self-serve, it's always good to have like free users who love to try things. And kind of we use like a lot of like A/B testing. So if we ship something that might be critical and might affect things, we actually roll it out as an A/B for a few users and leave it for like a week or two, depending on how much the risk is coming. And if things are working well, and we've seen that they work well, we just promote it. Now, in the past, that used to be very expensive because, OK, now we want to promote it. What can we do? Should we like delete all the code and migrate it? If we realize it's buggy, how we do this? But now, because LLMs are there, the cost of redoing things and like having the A and the B and the C, it becomes much cheaper. And so just to summarize, like we now like pretty much 100% of the code is generated for us internally because we focus a lot more on ensuring the code works. We do quite a lot of like prod deploy twice a day, and we focus so much on recovery time. So if there is something that is like went wrong or we detected a bug, we design the system so that it makes it much easier for us to just recover quickly. And this goes all the way into documenting your repository and adding context. So if we ship something, the linear ticket has to be very well documented, even like referencing, if we have a user call, even referencing the transcription in Notion, let's say we use like Notion or Granola, referencing that in the linear ticket where the LLM that writes the code have access to the linear ticket to understand the context of that. Then when a bug comes in, the LLM that goes and fixes it can actually understand why we've shipped this in the first place. And I think this is where most of what we realized the power came from when we started doing that, when we started actually adding more of the human context into the repo and making the repository like very LLM friendly. It's the stakeholders and LLMs. Anything that you do outside, any meetings that we do, everything is transcribed. Even like side discussions, we save it, we transcribe it, we add a link to it so the LLMs can see the context. And just one example, like even with all this, sometime we had an incident where like we shipped something that well tested, but it affected that one power user for a certain condition, and we had to like spend the entire Friday night. So like big advice, like don't ship production on Friday nights because obviously like if something went wrong, you have to spend the night. But one thing that helps quite a lot is again having that context of what is for the LLMs to see, okay, why did we even ship that? And this has helped us like recover quite quickly and even fixing that bug. And so yeah, from that incident, we learned all the stuff that I mentioned about having chain logs, having linear tickets, and basically just optimize for fast recovery. Because they're always going to be things that break. It's just how fast can you make sure that you recover. And to summarize, my biggest 3 takeaways is LLMs are now the stakeholders. They're not developers. So developers need to make sure that everything is well documented. All your thoughts, everything has to go into the repo. Every folder, every structure has to be indexed really well. Make sure all the context is there. And whatever you write in that documentation has to be LLM friendly. And what that means is sometimes, and you're always going to need to refine the architecture. Like I'll give you one example. If we notice sometimes LLM generate tests on like on the side, like generate tests for what it does. So what we did is we actually refactored the file structure to make that is the testing folder. Because we've seen LLMs tend to do it. So treat LLM biases as like a signal for you to re-architect the structure of the code. Because at the end, like LLMs are always going to bias to their pre-training data. And the closer your structure is to their pre-training data, the less chances you will have in like hallucination. Invest in the environment. I mentioned this, like making sure that you can spin your entire product as an isolated cluster where LLMs can do whatever they want. They can test, they can break things, they can do things. That is nothing to do with production data. And the gap between vibe coding and production has been about the testing environment right now. Because LLMs are getting better. And like the complexity of the code is also improving. It's all about how to make sure that you have a really good testing environment to make sure the code is trustworthy. And yeah, that's it.
Amazing. Thank you very much. We have time for one short question. I saw you have one, so one, and then we go.
Do you run into problems when switching to switching models?
Sorry?
Do you run into problems when switching models?
Yeah. That's actually one of the big thing is even so re-architecting has to be part of your system, because if you switch, so now for example we're switching to a cheaper models like Composer 2.5 instead of Opus and so on, but then we started to noting some regression, so we had to like redo some of the documentation into the repository. So I'm saying that's going to be an ever change, like a ongoing problem, and that's why making sure that whatever you write in your structure is going to change again, and that's why refactoring and should always be like a constant thing. But with LLM, that is much cheaper to even refactor using like the Opus models to refactor the documentation itself, say that cheaper models can actually operate better.
Amazing. Thank you very much.